In recent years, seafood consumption has increased significantly due to its nutritional benefits and raising global population. However, if we relied only on traditional fishing from the oceans, it would not be enough to meet this demand. Overfishing has already caused a decline in many fish population. So how are we managing seafood production today? And the answer is aquaculture. Yes, let's start by learning the definition of aquaculture. Aquaculture is the controlled breeding, rearing, and harvesting of aquatic organisms such as fish, shellfish, and seaweed for food, trade, and conservation. It is also known as fish farming. Unlike traditional fishing, which depends on natural fish stocks in oceans and rivers, aquaculture cultivates aquatic life in a controlled environment like ponds, tanks, and cages. It includes freshwater, brackish water, and marine environments, which takes place in inland farms, coastal regions, or even the offshore of ocean setups. With increasing seafood demand and declining wild fish population, aquaculture is an important alternative to capture the fishes. So it also has several important roles in food security, economic development, and environmental conservation. If we talk about food security and nutrition, with a growing population, aquaculture ensures a steady supply of fish and seafood, which are rich in proteins and essential nutrients like omega-3 fatty acids. So it provides an affordable source of protein, especially in developing countries where seafood is a dietary staple. And if we talk about economic growth and employment, aquaculture generates jobs in rural and coastal areas, creating employment for fish farmers, laborers, transporters, and traders. So it is a major contributor to the economy, where India is ranking among the top aquaculture producing countries. So aquaculture contributions also seen in conservation of wild fish stocks, because overfishing has led to decline of fish population in oceans, river, and lakes. So aquaculture reduces pressure on wild fish stocks by providing an alternative source of seafood. And they also contribute in environmental sustainability and the blue economy. So this blue economy promotes sustainable use of ocean resources for economic growth, which improve livelihoods and environmental health conditions also, while they play a vital role in sustainable coastal management by ensuring that marine resources are used responsibly. Okay, so besides fish, aquaculture also includes shrimp, prawn, oyster, crabs, and even aquatic plants like seaweed and algae. So expanding food and commercial opportunity. So here India is one of the largest aquaculture producer, with the state of Andhra Pradesh, West Bengal, and Tamil Nadu leading in fish farming. If we look into the history and evolution of aquaculture, aquaculture has existed for thousands of years, evolving from simple pond farming to scientific, where technology driven fish production. So the history of aquaculture reflects the human efforts to develop a reliable and sustainable source of aquatic food. So in ancient aquaculture practices was seen in one of the earliest record of China, where the Chinese people farmed crab in ponds. So they observed that certain fish species grow well together and began selective breeding. And if we talk about Egypt and Rome, where Egyptians kept the fish in ponds along the Nile River to ensure steady supply, where they built sophisticated fish tanks connected to the seawater for culturing species like oysters and mullets. If we talk about India, in medieval period, fish farming was practiced in village ponds, temple tanks, and even in the artificial reservoirs like built tanks. So fish like rohu, katla, and mrigal were cultivated in these community water bodies. So the traditional integrated farming included fish cultivation alongside the agriculture and livestock. And later, if we come to the modern development in aquaculture, during 19th and 20th centuries, scientists developed artificial breeding and hatchery technique to increase fish population control, which improved feed formulation for better growth rates and expanded commercial aquaculture, transitioning from small scale village practices to large scale commercial production. So we can say that 19th and 20th century saw major advancement in breeding, feeding and commercial fish farming. So in recent 20s, the genetic improvement was upgraded by selective farming and genetic modification have led to the faster growing and disease resistant fishes. So for example, genetically improved farmed tilapia was developed in 1990s. At the same time, integrated multi-tropic aquaculture system combines different species of aquatic animals in a single farm. So what was happening here? The waste from one species became food for another species. So it was reducing the pollution and also improved the efficiency. And the third one was biofolic technique. It is a sustainable method of fish farming where it reduces the water exchange by using beneficial microbes, and at the same time it helped to convert fish waste into useful nutrients by minimizing the environmental impact. Basically relied on the scientific advancements to improve efficiency, sustainability and productivity. Here I have a question. Can all fish survive in the same water type? And what happens if a freshwater fish is placed in a seawater? So this type of question leads to the importance of water salinity in aquaculture, right? And how different species require specific conditions to grow. So based on the water salinity, aquaculture is broadly divided into three types. That is freshwater aquaculture, where fishes are formed in lakes, rivers, ponds in a fresh water. For example, carp, katla and tilapia. And the second we have brackish water aquaculture. So this is a type of water which is combination of fresh water and marine water. By creating a moderate salinity in the water, we culture or we farm the fishes. So which is found in coastal areas, and the examples are shrimp and milkfish. Marine aquaculture, the farming takes place in ocean and coastal waters where with high salinity. So examples are salmon, oysters and seaweed. So India is the second largest producer of the freshwater fish like rohu and katla. Countries like Norway and Japan are leaders in marine salmon farming. So the answer is different fish species require different water types. So freshwater species cannot survive in marine environment and then vice versa. So there's one more classification which is based on how the aquatic animals are managed and controlled. So the first type is extensive aquaculture, where low stocking density happens. So it is actually a traditional village pond culture or a traditional fish farming where fish are grown naturally with no extra feeding. So these fishes relies on natural food like algae and plankton. And the second one is semi-intensive aquaculture. So it is a moderate stocking where a commercial shrimp farm that uses partial food supplement. So they use some artificial feed and have a better water management. And the third one is intensive aquaculture. So it is a modern fish farming where fish grow in tanks with oxygen control and automated feeding. So high stocking density, controlled environment and artificial feeding, aeration and air articulation has been set up in the whole system. These are the types of aquaculture where one is based on water salinity and the one is based on the production system. And let's move on to the common aquaculture species. If we talk about finfish or fish farming, in freshwater we have rohu, katla, tilapia and pangit, where in brackish water we have milkfish, mullet. When it comes to marine, we have salmon and sea bass. At the same time, if we talk about crustacean farming or shellfish, shrimp and crabs are the examples. And the next, which are molluscans, for example, oysters. If we move into the seaweed farming, for example, glacialaria and Capaphyllus, where it is cultivated for biofuel, food and cosmetics. Aquaculture has evolved from traditional method to modern techniques. So to increase efficiency, sustainability and profitability. So some methods require large water bodies like ponds and cages, while other require closed system with water recycling or urban and high value fish farming. So first we'll talk about the traditional aquaculture system, where this has been used for centuries and require minimal technology. So the first one is pond culture, where the fish are grown in small or large ponds, where the farmers control water levels, feeding and fish population. With it is low cost and easy to maintain and provides natural food resources. Then if we talk about cage culture, here fishes are raised in cage floating in natural water bodies like rivers, lakes and sea. So these water flows freely, providing oxygen and nutrients. This uses existing water bodies, reducing land use, and also allows high density fish farming. And if we talk about pen culture, which is similar to the cage culture but uses fenced enclosures in shallow waters. So fishes can access natural food while being protected from predators. And it is also low maintenance, utilize the natural habitat and better survival rate than the open water culture. If we move into the modern and advanced aquaculture system, we have recirculatory aquaculture system. It is a closed system where water is continuously filtered and reused. So oxygen level is controlled, waste from the water will be removed and disease prevention will also be maintained. So which is used for urban aquaculture and high level species like salmon and trout. So it uses 90% less water than the traditional farming and allows fish farming even in cities. So the second one is biofloc technology. So this uses microorganisms like bacteria, fungi or algae to maintain the water quality. So the fish waste is converted into protein rich feed for the fish, popular for shrimp and tilapia farming. So they reduces feed cost by 30 to 40% and prevents disease by improving water quality. And thirdly, we have integrated multi-tropic aquaculture. So this is different method where different species are grown together to optimize resource use. For example, fish, seaweed, shellfish grown in the same system. So seaweed absorbs excess nutrients, keeping the water clean. So they are mutually helping each other in the ecosystem. They are very eco-friendly and reduces the waste and produces multiple products like fish, plants and shellfish in one system. And the fourth one is aquaponics. So aquaponics is a technology where it is a combination of fish farming and hydroponics, whereas you are cultivating fish at the same time growing plants without soil. The fish waste provides nutrients for plants and plants clean the water. So use of vegetables like lettuce, basil and tomatoes along with tilapia and catfish. So this is a sustainable and water efficient method which uses 90% less water than traditional farming and produces both fish and crops at the same time. So India is increasing its focus on modern aquaculture to boost fish production and exports. So by choosing the right technique depending on sources, cost and environmental impact. Let's move on to the nutrition and feed management. So fish and other aquatic organisms require proper nutrition for growth, immunity and reproduction. In natural habitats, they feed on planktons, algae and small organisms. However, in aquaculture, feeding must be carefully managed to ensure healthy fish growth and reduced cost. Types of feed in aquaculture: one is natural feed, one is artificial feed and the third one is live feed. See, what is natural feed? So natural feed is occurring food in water that supplies fish nutrients and growth. So for example, as we all know, a plankton, algae and microorganisms. So this natural feed is rich in proteins and essential nutrients but is often not sufficient for commercial fish farming. So additional feed is sometimes required. So here comes the additional feed, that is artificial feed, where the man-made feed formulated for specific nutrients requirements of fish. So for example, pellets, which are processed fish feed containing proteins, fats and vitamins, and extruded feeds. So these are high energy feeds that float in water. And there is also a sinking feeds which is used for bottom feeding fish like catfish. This artificial feed ensures faster growth, higher survival rates and improved fish quality in commercial aquaculture. And then comes live feed. So this is a use of small live organisms to feed the fish like larvae and juvenile fish. So for example, brine shrimp, which is essential for larval fish nutrients, and rotifers, where small zooplanktons used for hatchery reared fishes. Copepods were high protein food for young fish and shrimps. So this live feed is crucial for early stage of fish development. Here we talk about health and disease management, because disease in aquaculture can cause mass mortality leading to economic loss, and infection diseases can spread rapidly in densely populated fish farms. There are few of the common disease in aquaculture, that is viral disease, bacterial disease and fungal disease, where the viral disease is caused by virus which is difficult to treat, bacterial disease which are caused by bacteria and can be treated by antibiotics. At the same time, fungal disease are often resulted from the poor water quality. There are major aquaculture diseases. First one is water spot disease, which affects the shrimp and caused by the virus. And the second one is columnarias disease, which affects fishes and caused by bacteria. And the third one is epizootic ulcerative syndrome, affects the freshwater fishes and caused by the fungal. These are the major diseases which we see in the aquatic animals or in aquaculture. So, if we talk about prevention and control strategies, first one is water quality management. The pH balance should be maintained, keep water at optimal pH range. Oxygen level should be maintained, where proper aerations has to be taken place, and ammonia control. So we should avoid excess waste buildup which can stress the fish and promote diseases. The second one is use of probiotics and immunostimulations. So good bacteria added to water or feed to improve the fish health, and natural compounds should be added to enhance the fish immune responses. Vaccination in high value species. So we have to vaccinate, which provides the long term protection against major infection. And biosecurity measures. So quarantine new fishes before introducing them into the farm, and regularly disinfect farm equipment to prevent pathogen spread, and we should monitor fish behavior and health daily. So water quality and biosecurity are the best defense against the diseases. Aquaculture also encounters environmental and sustainability concerns. So what are the challenges they come across? They are water pollution due to excess feed and antibiotics. In intensive aquaculture system, fish are often fed artificial diets, and unconsumed feed and fish waste accumulate in the water bodies, which causes the excess nutrition and depletion in oxygen and growth of algal blooms. So the use of antibiotics and chemicals to prevent fish disease can pollute surrounding water bodies and harm the natural ecosystem. And loss of mangroves due to shrimp farming. So shrimp farming in coastal areas has led to the destruction of mangroves forest in India, especially in the state like Andhra Pradesh, Tamil Nadu and West Bengal. So these mangroves act as a natural barriers against their loss, increases coastal erosion and vulnerability of cyclones. Mangrove deforestation reduces breeding grounds for fish, carps and other marine life, impacting biodiversity. And the third one is spread of invasive species affecting biodiversity. So some fishes species used in aquaculture like tilapia and African catfish are invasive, meaning they outcompete native species and disrupt local ecosystem. So these species spread beyond farms into river and lakes, reducing biodiversity and harming the local fish population. So introduction of disease-prone exotic species can lead to the large-scale fish dies of an economic loss. So unregulated farming of exotic species threatens biodiversity, and native species should be promoted for sustainable aquaculture. And to overcome this challenge, eco-friendly and sustainable methods must be adapted. So eco certification like ASCs, MSCs for responsible farming. So what is ASC? It is a Aquaculture Stewardship Council, and MSC is Marine Stewardship Council, are global organization that certify responsible fish farming practices. So these farm allow eco-friendly practice, use clean safe feed for the fishes. The Coastal Aquaculture Authority of India is promoting certified shrimp farming to reduce environmental damage. Consumers can support sustainable seafood by choosing eco-labeled products in markets. And waste recycling. In waste recycling, biofloc and IMTA methods are used. As I already said about biofloc, it is a method where microbes convert fish waste and uneaten feed into the proteins, reducing the pollution and cutting feed cost. So, popular in shrimp and tilapia farming in India due to its low environmental impact. If we talk about integrated multi-tropic aquaculture IMTA, where it is a technique, as we discussed, where it includes fish, shellfish, and seaweed in farming together. So this is used in Kerala and Tamil Nadu coastal regions. So waste recycling methods like biofloc and IMTA reduce pollution and improve the farm sustainability. And polyculture farming to enhance the ecological balance. Here, what is polyculture? So, polyculture is a farming technique where multiple species together in the same pond to create a natural ecosystem. So, for example, fish, shrimp, and other aquatic plants of each species are grown in a same farm and support each other in the ecosystem. They reduce disease outbreak by breaking the disease cycle, maximize space and resource, making farming more profitable, and which also enhances biodiversity by mimicking natural aquatic ecosystems. So, aquaculture policy. Government also have played a role in aquaculture policies, and there are few government initiatives in India to enhance the fisheries and aquaculture for the global economic. Department of Fisheries, Government of India. It is a part of Ministry of Fisheries, Animal Husbandry and Dietary, which is responsible for policy making, development programs and regulations of aquaculture and fisheries in India. So it works to increase fish production, support fish flow and promote sustainable aquaculture. It implements schemes like Pradhan Mantri Matsya Sampada Yojana. And later, Marine Products Export Development Authority regulates and promotes seafood exports from India, which ensures quality control and adheres to international standards, encourages modern aquaculture practices for export-oriented fishes. National Fisheries Development Board. So this focuses on fish production enhancement, infrastructure development and training programs, and works with state governments to boost fish farming, cold storage and processing industries, and also supports initiatives like biofloc technology and recirculating aquaculture system. If we talk about major government schemes in fisheries, that is Pradhan Mantri's Matsya Sampada Yojana, which increase fish production and productivity, improve fishermen's income and livelihood security, and promote sustainable fishing practices and exports. At the same time, Blue Revolution. So this revolution transformed fisheries into a modern and sustainable sector which promote advanced aquaculture techniques by enhancing marine and inland fish production. And the third one is Fisheries Infrastructures Development and Fund, which provide financial support for building fisheries infrastructure, develop cold storage, fish markets, and processing units. Also strengthens fishery supply chain in India. As we know that aquaculture also play a role in economic and social growth of India, how do they contribute? They contribute to GDP of India, making India as the second largest aquaculture producer globally, where fishery and aquaculture contribute about 1.24% to India's GDP and 7.28% to agricultural GDP. It provides a steady source of income for millions of farmers and laborers. The growth rate of aquaculture in India is higher than the other agriculture sector, making it an important industry for national economic development. By employment generation, it supports millions in coastal and rural areas where fisheries and aquaculture sector supports over 28 million people in India, providing employment in fish farming, processing, packing, transportation, logistic and export industries and businesses. Fish feed production and hatchery operation also. Export market, frozen shrimp and fish contribute significantly to foreign exchange earnings, where frozen shrimp and fish are India's top seafood exports. So in In 2022 to 2023, India exported 1.75 million metric tons of seafood, earning over 8 billion USD in foreign exchange. Shrimp alone contributes over 70% of India's total seafood exports. In conclusion, aquaculture is a vital sector that not only provides fish farming but also ensures food security, economic sustainability, and ecological balance. It meets global seafood demand, creates jobs, and supports rural and coastal communities. Scientifically and sustainably managed, aquaculture can protect marine biodiversity while maintaining a steady supply of fish and seafood. Balancing food production with environmental conservation is crucial, and scientific practices can boost productivity. This is all about aquaculture. If you find this video informative, don't forget to like, comment, and share, subscribe. Thank you.